Tonight we're going to talk about the space between galaxies. Not the galaxies themselves, not the stars inside them, but the vast stretches of almost unimaginable emptiness that separate one island of stars from the next. Because when most people picture the universe, they imagine it as a place filled with objects, planets, stars, nebulae, galaxies, bright things scattered through darkness. Yet the deeper astronomers have looked into the cosmos, the more they have discovered something unexpected. The universe is not defined by the things it contains. It is defined by the enormous emptiness between them. And that emptiness is so vast, so complete, that it begins to change the way we think about distance, time, and even existence itself. Before we begin, take a moment to settle in. Allow your attention to drift away from the concerns of the day. Let the scale of ordinary life grow smaller. Because tonight we are going to leave behind the familiar world entirely and travel outward into some of the largest structures that exist anywhere in reality. If you step outside on a clear night and look up, every star you can see belongs to the Milky Way. Every constellation, every bright point of light, every familiar pattern humans have named for thousands of years. They all exist inside the same galaxy. The Milky Way stretches roughly 100,000 light-years from edge to edge and contains hundreds of billions of stars. Even that number is difficult to fully absorb. Hundreds of billions. A population so large that if you counted one star every second without stopping, the task would take longer than human civilization has existed. Yet despite its enormous size, the Milky Way is only one galaxy among trillions. And beyond its outermost stars begins a region of space unlike anything we encounter in daily life. A region so empty that it pushes against the limits of human intuition. Far beyond the edge of our galaxy sits the Andromeda Galaxy, the nearest large spiral galaxy to our own. Its distance is approximately 2.5 million light-years. The light arriving from Andromeda tonight began its journey long before written history. Long before the first cities. Long before agriculture. Long before the earliest monuments were raised. Generation after generation of human beings lived entire lives while those photons crossed the darkness between galaxies. Only now are they arriving. Only now are they entering your eyes. And perhaps the most remarkable part of that journey is what they traveled through. Almost nothing. The space between the Milky Way and Andromeda is called intergalactic space. It is one of the most desolate environments known to science. Inside our own galaxy, the space between stars contains thin clouds of gas and dust, sparse by earthly standards but still present. Intergalactic space is different. In some regions, the density falls below a single atom per cubic meter. Imagine a volume of space roughly the size of a washing machine. Now imagine that inside that entire volume there may be only one solitary atom. Sometimes even less. No sound. No wind. No drifting clouds. No nearby stars. Just darkness stretching across millions of light-years. And yet even here, the universe leaves behind a faint trace of its beginning. Every region of space is filled with the cosmic microwave background. Ancient radiation left over from the birth of the universe itself. This faint afterglow has been traveling through space for nearly 14 billion years. It fills the voids between galaxies. It fills the interiors of galaxy clusters. It passes through planets and stars and living things. A quiet reminder that no matter how empty space appears, it still carries the memory of creation. The temperature of this radiation is only 2.7 degrees above absolute zero. Barely warmer than the coldest temperature nature allows. And yet it surrounds everything. Even the deepest void is not completely empty. It still contains the fading echo of the beginning. The more we learn about these immense distances, the more we discover that emptiness itself has structure. The universe is not a random scattering of galaxies. It possesses an architecture. A vast cosmic design built by gravity over billions of years. Galaxies gather into groups. Groups gather into clusters. Clusters gather into superclusters. And between them lie enormous regions where almost nothing exists at all. The darkness between galaxies is not simply unused space. It is part of the universe's fundamental structure. In fact, most of the cosmos consists of these immense voids. The stars, planets, nebulae, and galaxies that capture our attention occupy only a small fraction of the universe's total volume. The overwhelming majority is silence. The overwhelming majority is distance. The overwhelming majority is emptiness. And perhaps that is why the universe feels so profound. Because everything we know exists as islands of light floating within an ocean of darkness so large that even galaxies begin to look small against it. If the distance between the Milky Way and Andromeda already feels enormous, it helps to remember just how large our own galaxy is before attempting to grasp what lies beyond it. The Milky Way stretches roughly 100,000 light-years across. Hundreds of billions of stars are spread throughout its spiral arms, orbiting a central region that itself contains a supermassive black hole millions of times more massive than the Sun. Entire civilizations could rise and fall for millions of years without ever crossing even a tiny fraction of that distance. Yet when astronomers say that Andromeda is 2.5 million light-years away, they are describing a gap 25 times wider than the diameter of our entire galaxy. 25 Milky Ways placed side by side would still struggle to bridge the darkness separating us from our nearest large galactic neighbor. What makes this realization so unsettling is that Andromeda is not considered distant by cosmic standards. It is local, familiar, practically next door. If the Milky Way were a house standing alone in the countryside, Andromeda would be the neighboring house visible from the porch. The fact that 2.5 million light-years can qualify as a neighborhood distance tells us something important about the universe. The scales involved are so large that language begins to lose its usefulness. Numbers continue to function mathematically, but emotionally they stop meaning what they once did. A million becomes interchangeable with a billion. A billion begins to feel no different from a trillion. Human intuition evolved to understand forests, rivers, mountains, and seasons. It did not evolve to comprehend structures measured in millions of years of travel at the speed of light. The local group, the galactic family to which the Milky Way belongs, spans roughly 10 million light-years from one side to the other. It contains around 80 known galaxies, although most are small dwarf galaxies orbiting larger systems like the Milky Way and Andromeda. To us, these galaxies appear isolated and independent, but gravity quietly binds them together into a larger structure. Over billions of years, they dance around one another in slow motion, tracing paths so gradual that an entire human lifetime would reveal almost no movement at all. The cosmos operates on timescales that make patience itself seem hurried. Beyond the local group lies something larger still. Roughly 50 million light-years away sits the Virgo cluster, a collection containing more than 1,000 galaxies gathered together by gravity. Between the outskirts of our local group and the Virgo cluster stretches an immense gulf of intergalactic space. 40 million light-years of darkness. 40 million years of travel even for a beam of light moving at nature's ultimate speed limit. If a traveler somehow began such a journey when the first dinosaurs appeared on Earth, they would still not have arrived. Continents would have drifted. Species would have emerged and vanished. Entire chapters of planetary history would have unfolded while the traveler remained suspended within the same crossing. Yet the Virgo cluster itself is only one node within a much larger pattern. During the 20th century, astronomers gradually discovered that galaxies are not sprinkled randomly through space. Instead, they arrange themselves into enormous structures that stretch across the universe like threads woven into an invisible tapestry. When galaxy surveys became detailed enough to map millions of galaxies simultaneously, a hidden architecture emerged. The universe resembled a web. The name astronomers chose was simple and surprisingly accurate: the cosmic web. Imagine looking at frost spreading across a winter window pane. Thin branches split and reconnect, creating intricate patterns of structure surrounded by empty spaces. Now imagine that pattern expanded to billions of light-years in size. Galaxies gather along vast filaments that stretch across the observable universe. These filaments intersect at dense nodes where galaxy clusters form. Between them lie enormous voids, regions so empty that they contain only a tiny fraction of the matter found elsewhere. At first glance, this arrangement seems almost artistic, as though some hidden hand organized the cosmos into a grand design. Yet the explanation is remarkably simple. Gravity, tiny fluctuations in density existed shortly after the birth of the universe. Some regions contain slightly more matter than average, others contain slightly less. The differences were incredibly small, only about 1 part in 100,000, but gravity is patient. Given enough time, even the smallest imbalance becomes significant. Regions that began slightly denser pulled in more matter. Regions that began slightly emptier lost matter to their neighbors. Over billions of years, those tiny differences grew into the vast cosmic web we observe today. The result is a universe whose largest structures emerged from some of the smallest variations imaginable. Entire superclusters of galaxies can trace their origins back to fluctuations so subtle they would have been almost impossible to notice in the newborn cosmos. There is something deeply humbling in that thought. The largest structures in existence began as nearly invisible imperfections. The cosmic web also reveals an uncomfortable truth about our place in reality. Most of the universe is empty, not mostly empty in the casual sense but overwhelmingly empty. The filaments containing galaxies are spectacular, the clusters are magnificent, the stars and planets inspire endless fascination, yet together they occupy only a small fraction of the universe's total volume. The voids dominate everything. Astronomers estimate that roughly 80% of the observable universe's volume consists of these enormous underdense regions. Imagine a vast three-dimensional foam. The galaxies trace the thin walls separating bubbles while the bubbles themselves contain almost nothing. We live on one of those walls. We naturally focus our attention on the structures because that is where all visible matter resides. But from the perspective of volume alone, the emptiness is the true ruler of the cosmos. Some voids are so immense that they challenge comprehension. The KBC void, one of the largest known structures surrounding our region of space, stretches roughly 2 billion light-years across. To appreciate that distance, consider that light itself requires 2 billion years to travel from one side to the other. During such a journey, Earth's continents would rearrange themselves many times over. Entire branches of life would appear, flourish, and disappear. Mountains would rise and erode back into dust. The sun would continue burning steadily, while civilizations came and went in numbers beyond counting. Yet even a void of that scale is not entirely empty. Here and there, isolated galaxies drift through the darkness. These are known as void galaxies, among the loneliest objects in the observable universe. While galaxies within clusters constantly interact with neighbors, merging and exchanging material, void galaxies often spend billions of years in relative isolation. Their nearest major neighbors may be 50 million or even 100 million light-years away. If intelligent beings lived within one of these galaxies and looked outward into the night, they would see a profoundly different universe than we do. The sky beyond their own galaxy would appear almost completely dark. There would be no bright neighboring systems like Andromeda, no nearby clusters of galaxies, only faint smudges visible through powerful instruments, scattered across an ocean of blackness. It is difficult not to feel a sense of cosmic solitude when imagining such a place. We often think of ourselves as isolated, living on a small world around an ordinary star. Yet compared to civilization inside a deep cosmic void, we inhabit a bustling neighborhood. We live surrounded by nearby galaxies embedded within rich cosmic structure. The universe could have appeared far lonelier than it does. And perhaps that is one of the strangest lessons hidden within the cosmic web. Distance is not merely a measurement, it shapes perspective. It shapes what can be seen, what can be known, and even what questions can be asked. The structure of the universe determines the limits of observation itself. Some regions of space enjoy views of countless neighboring galaxies. Others gaze outward into darkness so complete that the larger architecture of the cosmos becomes almost impossible to detect. The web stretches onward in every direction, beyond clusters and superclusters, beyond the largest maps humanity has ever created. Vast threads of galaxies span hundreds of millions of light-years. Enormous voids separate them. Gravity slowly pulls matter into dense regions while expansion simultaneously stretches the distances between them. The entire structure resembles something alive, breathing on timescales measured not in years or centuries, but in billions of years. And through all of it, light continues its patient journey, crossing the filaments, crossing the voids, crossing distances so immense that entire histories unfold while a single photon remains in transit. The universe is not merely large, it is organized largeness, a vast architecture built from gravity, time, and emptiness itself, stretching far beyond anything the human mind was ever designed to imagine. There is something even stranger than the emptiness between galaxies, stranger than the cosmic voids, stranger than the realization that most of the universe consists of almost nothing at all. It is the fact that the distances themselves are not fixed. The darkness between galaxies is not standing still, it is growing. For most of human history, space was imagined as a stage, a vast, motionless arena within which stars and planets moved about like actors. The backdrop itself was assumed to be permanent and unchanging. Even after astronomers began to understand the immense scale of the cosmos, many still imagined the universe as something fundamentally static. Galaxies might orbit, stars might explode, but the universe itself simply existed. Then, in the early 20th century, observations began to reveal something extraordinary. The galaxies were moving apart. At first, the discovery seemed almost impossible to believe. When astronomers analyzed the light arriving from distant galaxies, they found that the wavelengths had been stretched. Colors shifted subtly toward the red end of the spectrum. The farther away a galaxy appeared, the greater this shift became. The pattern was unmistakable. Nearly every galaxy beyond our local neighborhood was receding. The universe was not static. It was expanding. The implications were profound. If galaxies were moving away from one another today, then they must have been closer together in the past. Follow that idea backward far enough and it leads to a universe that was once compressed into an extraordinarily hot and dense state. The discovery of cosmic expansion transformed astronomy forever. The universe was no longer a fixed structure, it had a history. But even that realization hides something deeper. When we say that galaxies are moving apart, the wording can be misleading. It suggests galaxies flying through space like ships crossing an ocean. That is not what is happening. The galaxies are largely staying where they are relative to their local surroundings. Instead, the space between them is expanding. Imagine raisins embedded within a loaf of bread as it rises in an oven. As the dough expands, every raisin moves farther from every other raisin. None of them are actively traveling through the dough. The dough itself is stretching. The universe behaves in much the same way. Space is not merely an empty backdrop. Space itself participates in the evolution of the cosmos. The implications become astonishing when we begin examining truly large distances. The light arriving from Andromeda tonight crossed 2.5 million light-years of space. Over that distance, cosmic expansion has very little effect because Andromeda and the Milky Way are gravitationally bound to one another. Gravity is strong enough locally to overcome the gentle stretching of the universe. But beyond the local group, expansion becomes increasingly important. Galaxy clusters drift farther apart, superclusters separate, vast regions of the cosmic web slowly stretch away from one another. The larger the scale, the more expansion dominates the story. This means that when astronomers measure distant galaxies, they must confront an unusual problem. The light reaching us left its source billions of years ago. During that immense journey, the universe continued expanding. The galaxy that emitted the light is no longer where it was when the photons began their voyage. It is farther away now. Sometimes much farther away. Imagine receiving a message from someone who mailed it while standing in one city, only to discover that during the delivery process the city itself drifted hundreds of miles farther away. On cosmic scales, something similar happens constantly. The universe changes while light is traveling through it. This creates a remarkable distinction between two different kinds of distance. There is the distance light has traveled and there is the distance separating us from the object today. For nearby galaxies, the difference is relatively small. For the most distant galaxies ever observed, the difference becomes enormous. Some of the earliest galaxies detected by modern telescopes emitted their light more than 13 billion years ago. At first glance, that might suggest they are 13 billion light-years away. They are not. Because the universe has been expanding throughout those 13 billion years, many of those galaxies now reside tens of billions of light-years from us. Their light has spent nearly the entire age of the cosmos crossing a universe that was continuously growing larger around it. The farther we look into space, the more we are forced to abandon common intuition. Distance becomes tied to time. Motion becomes tied to geometry. The universe refuses to behave like anything encountered in ordinary life. And nowhere is this more apparent than at the edge of the observable universe. When people hear that the universe is approximately 13.8 billion years old, they often assume the observable universe must therefore extend 13.8 billion light-years in every direction. It seems logical. If light has only existed for 13.8 billion years, surely that limits how far we can see. Yet the actual observable universe is far larger. Its radius is approximately 46.5 billion light-years. Its diameter is roughly 93 billion light-years. The reason is expansion. While light was traveling toward us, the universe itself continued stretching. The distant regions that emitted those ancient photons are now vastly farther away than a simple calculation based on age alone would suggest. The observable universe is therefore not a static sphere frozen in time. It is a dynamic horizon defined by the relationship between light, time, and expansion. And beyond that horizon lies something even more mysterious. The unobservable universe. Everything we can see exists within a cosmic sphere centered on our location. Not because we occupy a special place, but because light requires time to travel. Beyond the observable boundary, there are regions whose light has simply not had enough time to reach us since the beginning of the cosmos. Those regions are almost certainly filled with galaxies. Clusters, voids, filaments, entire structures as vast as anything we observe. Yet they remain permanently hidden. Not because they are too faint. Not because our telescopes lack power. But because the universe itself imposes limits on observation. There are places from which information can never reach us. This realization carries a strangely philosophical weight. Human beings often assume that with enough technology, every mystery can eventually be solved. Yet the universe appears to contain regions that may remain forever inaccessible. No telescope, no spacecraft, no future civilization can overcome the simple reality that some distances have become too large for light itself to bridge. There are galaxies existing right now whose current light will never reach Earth. The photons they emit today are already lost to us. Space expands too quickly. The gulf grows too fast. Their future has become disconnected from ours. They still exist, their stars continue burning, planets may orbit within them, entire histories may unfold across billions of years, yet from our perspective they have effectively vanished beyond a cosmic horizon. The thought is strangely haunting. Not because those galaxies are gone, but because they remain forever unreachable. Even in principle. As astronomers explored expansion more deeply, another surprise emerged. For much of the 20th century, scientists assumed gravity should gradually slow the expansion. Every galaxy pulls on every other galaxy. Over enough time, that mutual attraction should act like a cosmic brake. The universe should still be expanding, just more slowly with each passing era. Instead, observations revealed the opposite. Expansion is accelerating. The universe is not merely growing larger. It is growing larger faster and faster. Something appears to be pushing space apart. Something invisible. Something that permeates the cosmos itself. Astronomers call it dark energy. The name sounds mysterious because the phenomenon remains mysterious. Dark energy appears to account for roughly 68% of everything in the universe, yet its true nature remains unknown. It cannot be seen directly. It cannot be collected or studied in laboratories. Its existence is inferred from the way cosmic expansion behaves. And what it appears to be doing is quietly transforming the future of the universe. Every year, galaxies drift farther apart. Every year, the cosmic web stretches slightly wider. Every year, the great voids become slightly emptier. On human timescales, the change is imperceptible. Entire civilizations can rise and fall without noticing it, yet over billions of years the effect becomes overwhelming. Imagine standing on a shoreline while the tide slowly retreats. At first the change is barely visible. Then gradually the water pulls farther away, features once close begin disappearing into the distance. Eventually the shoreline becomes almost unrecognizable. The universe is experiencing something similar. Billions of years from now, distant galaxies will vanish beyond the observable horizon. Future astronomers may look outward and find only a fraction of the cosmic structures we see today. Evidence of the wider universe will gradually fade from view. The night sky itself will become lonelier. In the unimaginably distant future, only galaxies gravitationally bound to our own region of space may remain visible. Everything else will have slipped beyond reach, carried away by the relentless expansion of the cosmos. There is something deeply poetic about this. We often think of ourselves as arriving late in cosmic history. The universe is already nearly 14 billion years old. Entire generations of stars lived and died before Earth even formed. Yet in another sense, we exist during a remarkably fortunate era. The universe is old enough to have created galaxies, planets, and life. But it is still young enough that the grand architecture of the cosmic web remains visible. The evidence has not yet disappeared. The distant galaxies still shine. The ancient light still arrives. The story of cosmic history remains written across the sky for anyone patient enough to read it. And every photon crossing the intergalactic darkness carries part of that story. Every beam of light arriving from a distant galaxy has survived a journey through expanding space. It has endured billions of years of cosmic evolution. It arrives not merely as illumination but as information, a message from another era preserved across incomprehensible distances. The darkness between galaxies is not empty silence. It is an ocean through which the history of the universe continually travels. And even now, as countless ancient photons stream invisibly through the vastness between galaxies, the ocean itself continues expanding beneath them, stretching ever wider, carrying the cosmos slowly toward a future unlike anything that exists today. If the universe is a cosmic web, then the galaxies and clusters are its luminous threads. They are the structures that draw our attention. They are where stars are born, where planets form, where light gathers and history unfolds. But between those threads lie regions so vast and so empty that they challenge the very idea of what a place can be. These regions are known as cosmic voids, and they are among the strangest environments ever discovered. When most people imagine a void, they picture a gap between objects, a region where there simply happens to be less matter than average. But cosmic voids are not small gaps. They are not merely empty neighborhoods between galaxies. They are some of the largest structures in the known universe. Entire voids can span hundreds of millions of light years. Some stretch across distances so immense that thousands of galaxies could be placed side by side within them without filling the space. To cross one of these regions at the speed of light would require longer than complex life has existed on Earth. And yet, despite their enormous size, there is remarkably little inside them. A traveler moving through the heart of a large void might spend millions of years passing through darkness without ever approaching a major galaxy. The night sky would appear profoundly different from the one we know. Familiar landmarks would vanish. The bright concentrations of distant galaxies that populate our telescopic images would become sparse and scattered. The universe would seem quieter, simpler, almost abandoned. It is difficult to imagine such isolation because every environment humans have ever experienced is crowded by comparison. Even the most remote deserts on Earth contain life. Even the deepest oceans teem with organisms. Even Antarctica, often described as empty, supports entire ecosystems. Nature on Earth rarely leaves a place truly vacant. The cosmos has no such hesitation. The universe creates emptiness on scales that seem almost excessive. One of the most famous examples is the Boötes void, a region discovered in the 1980s that stretches roughly 330 million light-years across. To appreciate the scale of this structure, imagine replacing our entire local group of galaxies with empty space. Then expand that emptiness again and again and again until the distance becomes almost impossible to visualize. Within the Boötes void, galaxies exist, but far fewer than expected. Large regions contain almost nothing at all. When astronomers first discovered it, some wondered whether their observations were incomplete. Surely such an enormous absence could not be real. Yet as measurements improved, the void remained. It was not an error. It was a genuine feature of the cosmos. An immense region where matter simply never gathered in significant quantities. The existence of these voids tells us something important about how the universe evolved. Gravity pulls matter together, gradually building stars, galaxies, and clusters. But gravity can only work with what is available. In some regions of the early universe, slightly less matter existed than average. Over billions of years, those small deficits became larger and larger. Matter flowed outward toward denser regions, leaving the emptier areas increasingly barren. In a sense, the voids were emptied by gravity itself. The same force that created galaxies also created their absence. This idea carries an unexpected philosophical beauty. Creation and emptiness are not opposites, they are partners. Every galaxy cluster exists because matter accumulated there. Every void exists because matter left. The structures and the empty spaces emerged together, shaped by the same underlying processes. The universe sculpted itself by deciding where matter would gather and where it would not. And over billions of years, the contrast became increasingly dramatic. What makes cosmic voids particularly fascinating is that they continue evolving. Matter still drifts outward. Galaxies near the edges continue moving toward denser regions. The voids slowly grow larger. They expand like bubbles within the cosmic web, gradually pushing against the surrounding structures. If we could watch the universe evolve over trillions of years in accelerated motion, the process would resemble an immense cosmic breathing pattern. Dense regions would become denser. Empty regions would become emptier. The web would sharpen. The contrast between structure and void would intensify. The universe seems to prefer extremes. Yet even the emptiest regions are not entirely empty. A few isolated galaxies still wander through the darkness. These galaxies are among the loneliest objects known to science. Many have spent billions of years without experiencing significant interactions with neighboring galaxies. While galaxies inside crowded clusters constantly merge, collide, and exchange material, void galaxies often evolve in relative solitude. To imagine life inside one of these galaxies is to imagine a radically different perspective on reality. Here on Earth, astronomers can look outward and discover evidence of countless neighboring galaxies. The night sky, when viewed through powerful telescopes, reveals a universe overflowing with structure. We know we inhabit a vast cosmic network because we can observe it directly. But what if your galaxy existed deep within a void? What if every direction appeared nearly empty? What if the nearest major galaxy lay tens of millions of light years away? Would you even realize a larger cosmic web existed? The answer is not obvious. A civilization emerging within a sufficiently isolated galaxy might spend much of its history believing its own galaxy represented the majority of the universe. The evidence for larger structures would be faint, difficult to detect, perhaps impossible with early technology. Their picture of reality would be fundamentally shaped by where they happen to exist. This is one of the most profound lessons astronomy teaches us. Observation depends on location, knowledge depends on perspective. The universe does not reveal the same truths to every observer. Two civilizations separated by hundreds of millions of light years could develop completely different understandings of the cosmos simply because they inhabit different regions of it. We often imagine scientific truth as something universal and immediate. Yet much of what we know about the universe depends upon the fortunate position from which we observe it. We live in a galaxy surrounded by others. We live in an era when distant galaxies remain visible. We occupy a location rich enough in structure to reveal the larger architecture of reality. That may not always be true. And it may not be true everywhere. As scientists mapped larger portions of the universe, another curious pattern emerged. The voids were not random. They fit together with the surrounding filaments and clusters like pieces of an enormous puzzle. The cosmic web appeared surprisingly elegant, vast empty bubbles intertwined with luminous structures in a pattern that repeated across incomprehensible distances. Looking at these maps can evoke an almost unsettling reaction. The universe begins to resemble something organic. The filaments look like neural networks, like roots spreading through soil, like blood vessels branching through living tissue, like microscopic structures magnified to cosmic scales. The resemblance is largely coincidental. The physical processes involved are entirely different, yet the visual similarity remains striking. Nature often produces comparable patterns when simple rules operate across large systems. Whether one examines rivers, lightning, plant roots, biological networks, or the large-scale structure of the universe, recurring geometries emerge again and again. It is as though reality possesses a preference for certain forms. And among those forms, perhaps none is more important than the relationship between structure and emptiness. Because without the voids, the web would not exist. Without darkness, the light would have no shape. Without absence, presence would lose its meaning. The great cosmic voids remind us that emptiness is not a flaw in the universe. It is not unused space waiting to be filled. It is an essential part of the design. The voids help define the structures around them. They create contrast. They create scale. They create the conditions that allow galaxies to stand out against the darkness. The more deeply we explore the cosmos, the more we discover that nothingness is not merely the absence of something. It is a feature of reality in its own right. A silent partner in the formation of everything we see. And perhaps that is why these lonely regions feel so strangely compelling. They force us to confront an idea that rarely appears in everyday life. The universe does not require constant activity. It does not need every corner filled with stars and planets and events. It is comfortable with stillness, comfortable with silence, comfortable with vast stretches of darkness extending for hundreds of millions of light years. The voids simply exist. Patient, quiet, almost untouched by cosmic history. While galaxies collide, stars explode, and civilizations imagine their place among the stars, the great voids remain what they have always been. Enormous oceans of near-perfect emptiness, drifting silently between the brightest structures in existence, reminding us that the universe is defined not only by what it contains, but by what it leaves behind. For most of human history, the horizon seemed like a physical boundary. Stand on a shoreline and the world appears to end in the distance. The ocean meets the sky. Beyond that point, nothing can be seen. Ancient civilizations often imagined that the horizon marked the edge of the world itself, yet with travel came a remarkable discovery. The horizon was not a true boundary, it only appeared that way because of perspective. Move forward and the horizon moves with you, new landscapes emerge, new oceans, new continents. Again and again, humanity learned the same lesson. The horizon is not the edge of reality. It is merely the edge of what can currently be observed. As astronomy expanded our view of the cosmos, many assumed the same principle would continue forever. Every limit would eventually yield to better instruments. Every mystery would surrender to greater knowledge. Every horizon would move farther away. But the universe has revealed something deeply surprising. There are horizons that cannot be crossed. Not because of technological limitations. Not because of insufficient intelligence. But because reality itself imposes boundaries on what can ever be known. The observable universe is often misunderstood. The phrase does not mean the portion of the universe we have managed to observe so far, it refers to the portion that it is physically possible to observe. Everything beyond that boundary exists outside the reach of light itself. This distinction is crucial. If a galaxy lies beyond the observable horizon, building a larger telescope will not reveal it. Waiting another century will not reveal it. Waiting another million years will not reveal it. The limitation is woven into the structure of space and time. Light travels at a finite speed. The universe has a finite age. As a result, there are regions whose signals have simply not had enough time to arrive. Imagine standing inside an immense forest at night with a lantern. The light illuminates a circular area around you while darkness stretches beyond it in every direction. The illuminated region is not all that exists, it is merely all that can currently be seen. The universe operates in much the same way, except the lantern is time itself. Every year, more ancient light reaches us, revealing slightly more of cosmic history, yet even this process has limits. There are places so distant that their light will never arrive. Not tomorrow. Not in a trillion years. Never. This is one of the most profound consequences of cosmic expansion. As space stretches, distant regions recede from one another. Some are now moving away so rapidly that their future light can no longer overcome the expansion between us. The photons they emit today begin their journey toward Earth, but the space separating us grows faster than the photons can cross it. The gap continually widens. The message never arrives. The existence of such regions creates a strange form of cosmic isolation. We tend to think of the universe as a single connected entity, a vast but ultimately unified structure. Yet on the largest scales, parts of reality are becoming permanently disconnected. Entire galaxies are effectively slipping beyond communication. Somewhere, perhaps at this very moment, stars are being born in galaxies whose future light will never reach Earth. Planets may be forming. Civilizations may emerge. Entire histories may unfold. And none of it will ever become known to us. Not because those events are hidden. Not because they are secret. But because the universe itself prevents their information from crossing the growing distances between us. This realization introduces a humbling perspective on knowledge. Human beings often assume that reality and observation are closely linked. If something exists, then in principle it can eventually be discovered. The universe suggests otherwise. Existence does not guarantee accessibility. Reality extends beyond observation. There may be countless phenomena occurring beyond our cosmic horizon that no observer within our region will ever witness. The thought can feel unsettling at first. We are accustomed to treating ignorance as temporary. Questions exist so that answers may eventually follow. Mysteries exist so that they may be solved. Yet the cosmos contains mysteries that may remain mysteries forever. Not due to failure. Not due to lack of effort. But because some information lies permanently beyond reach. In a strange way, this makes the universe feel larger than any measurement could capture. The observable universe spans roughly 93 billion light-years in diameter. Already this number stretches comprehension to its breaking point, yet it may represent only a small fraction of the whole. Current cosmological models suggest the universe beyond our observable horizon could continue for unimaginable distances. Perhaps hundreds of times larger. Perhaps millions. Perhaps infinite. The truth is that we do not know. And remarkably, we may never know. The idea of an infinite universe carries a peculiar psychological weight. Human minds evolved in a world where everything has boundaries. Mountains end, oceans have shores, forests eventually give way to open land, even the largest structures encountered in daily life possess limits. Infinity does not. An infinite universe would contain endless galaxies, endless stars, endless planets. Every possible arrangement of matter permitted by physics could occur somewhere. Given sufficient distance, even extraordinarily unlikely events become inevitable. The implications are so strange that they border on the surreal. And yet infinity is only one possibility. The universe could be finite but vastly larger than the observable region. It could curve back upon itself in ways difficult to visualize. It could possess geometries unlike anything experienced in ordinary life. Modern cosmology offers possibilities, but certainty remains elusive. What makes this uncertainty fascinating is that it arises not from a lack of intelligence but from the structure of reality itself. The universe may contain questions that have no observable answers. Questions whose solutions exist beyond every horizon we can ever reach. There is something deeply beautiful about that. Human curiosity is often portrayed as a force that conquers ignorance. We celebrate discovery, we celebrate exploration, we celebrate the expansion of knowledge, yet perhaps curiosity serves another purpose as well. Perhaps its value lies not only in answering questions but in recognizing the vastness of what remains unknown. The observable universe is already more extraordinary than anything our ancestors imagined. Trillions of galaxies, cosmic webs spanning billions of light years, ancient light preserving a record of the universe's earliest moments. Black holes, dark matter, dark energy, and structures so large that entire clusters of galaxies appear small by comparison. And still we stand at the edge of a greater mystery. A boundary beyond which observation cannot pass. A horizon that no spacecraft can cross. A limit imposed not by engineering but by existence itself. Perhaps this is why the night sky continues to inspire wonder even after centuries of scientific progress. Knowledge has not diminished the mystery, it has deepened it. Every discovery reveals a larger context. Every answer exposes new questions. Every horizon reached reveals another horizon beyond it. The universe is not becoming smaller as we learn more. It is becoming larger. The more clearly we see, the more expansive reality appears. And somewhere beyond the furthest galaxies visible to our telescopes, beyond the oldest light we can detect, beyond the boundaries defined by time and expansion, the cosmos continues. Silent, unseen, carrying histories that will never intersect with our own. Entire regions of existence unfolding forever beyond observation. The great cosmic horizon is therefore not merely a scientific concept. It is a reminder that reality exceeds perception, that existence is larger than knowledge, that the universe contains more than any observer can ever witness. And perhaps that is exactly what makes it so endlessly captivating. Because even after everything we have discovered, even after mapping galaxies across billions of light years and tracing the history of the cosmos back toward its earliest moments, we remain surrounded by mystery. Not at the edge of understanding, but at the beginning of it. Standing within our small illuminated circle of knowledge while an immeasurably larger darkness stretches outward in every direction, waiting beyond the horizon, forever reminding us how vast reality truly is. When we look into the night sky, it is easy to assume that the universe has always looked this way. Galaxies fill the darkness, stars shine across enormous distances, nebulae glow with the light of newborn suns. Everywhere we look, the cosmos appears active, vibrant, and alive with energy. The night sky feels permanent, timeless, as though the stars have always been there and always will be. But the universe we see today is temporary. In fact, we happen to exist during an unusually bright chapter of cosmic history. The stars overhead may feel eternal when measured against the length of a human life, but compared to the lifespan of the universe itself, they are fleeting. Every star is living on borrowed time. Every galaxy is slowly spending a finite supply of fuel. Every source of light we observe tonight is participating in a process that cannot continue forever. The cosmos is not only expanding through space, it is moving through time. And time changes everything. The story begins inside the hearts of stars. Every star shines because gravity compresses matter with tremendous force. Deep within its core, hydrogen atoms collide and fuse into helium, releasing vast quantities of energy. That energy struggles outward through layers of superheated plasma before finally escaping into space as light. For billions of years, stars wage a delicate battle between gravity and radiation. Gravity tries to pull them inward. Energy produced by fusion pushes outward. The balance creates stability. But every star possesses a limited supply of fuel. No matter how large or small, every star is slowly consuming itself. Our own sun contains enough hydrogen to continue shining for roughly 5 billion more years. That sounds unimaginably distant from a human perspective. Entire civilizations could rise and vanish millions of times before the sun exhausts its fuel. Yet on cosmic timescales, 5 billion years is not forever. It is merely a chapter. Eventually, the hydrogen in the sun's core will become depleted. The balance maintaining the star will begin to change. The sun will swell into a red giant, growing so large that its outer layers may engulf Mercury and Venus. Earth's fate remains uncertain, but even if our planet survives physically, its oceans will long since have evaporated. The familiar world that nurtured life will become unrecognizable. And then, after shedding its outer layers into space, the sun will leave behind a white dwarf. A stellar ember. A slowly cooling remnant no longer capable of generating new energy through fusion. This fate is not unique. It is normal. Across the universe, stars are continuously being born and continuously dying. Massive stars live fast and perish in spectacular explosions called supernovae. Smaller stars endure for trillions of years, burning their fuel slowly and efficiently, yet eventually every star reaches its end. The universe is filled with clocks, and every star is one of them. For now, this process is balanced by new star formation. Giant clouds of gas collapse under gravity, creating fresh generations of stars. Some shine alone, others form in pairs or clusters. Entire galaxies continue producing stellar light. But even this cannot last forever. The raw material required to create stars is gradually being consumed. Every generation of stars locks matter into remnants, planets, black holes, and heavier elements. Over time, the available reservoirs of hydrogen become depleted. Star formation slows, then slows further, then slows again. The universe is not running out of matter. It is running out of easily usable fuel. Astronomers sometimes refer to the present era as the stelliferous era, the age of stars. It is the chapter of cosmic history in which stars dominate the visible universe. We are living near the middle of this age. The first stars appeared more than 13 billion years ago, and countless trillions more years remain before the final stars fade away. Yet even this enormously long period represents only a fraction of the future. If humanity somehow survived for 1 trillion years and looked up at the night sky, the cosmos would already appear different. Many galaxies would have vanished beyond the cosmic horizon due to expansion. New stars would still exist, but star formation would be slowing dramatically. The universe would be entering a quieter phase. After enough time passes, no new stars will form at all. The great stellar factories scattered throughout galaxies will finally fall silent. Imagine a universe in which every star that can be born has already been born. A universe where the darkness grows steadily larger because no new light enters the stage. At first, this seems like an ending. But in reality, it is only another transition. The stars that remain will continue shining according to their lifespans. Massive stars will disappear first. Medium-sized stars will follow. The smallest red dwarfs, burning fuel with extraordinary efficiency, may survive for trillions upon trillions of years. Some estimates suggest that the longest-lived stars could continue glowing for up to 10 trillion years. 10 trillion years. The number is so large that human history effectively disappears inside it. The entirety of recorded civilization occupies less than a microscopic fraction of such a time span. Every empire, every invention, every language ever spoken becomes a brief flicker compared to the future awaiting the cosmos. Yet even 10 trillion years eventually comes to an end. The last stars will fade. Not explode. Not collapse dramatically. Simply fade. Their fuel exhausted. Their light extinguished. The universe will enter a period unlike anything that exists today. A cosmos without starlight. A cosmos where the brilliant islands of illumination that define our night sky have largely vanished. It is difficult to imagine because starlight feels fundamental. Stars are the backdrop against which human existence unfolds. Every culture in history has known them. Every generation has looked upward and found familiar points of light. But there will come a time when no living observer, if any observers remain, can look into the sky and see what we see tonight. The stars themselves will become relics of the past. And yet the universe will not be dead. White dwarfs will remain. Neutron stars will remain. Black holes will remain. Countless stellar remnants will continue drifting through the darkness. Gravity will continue operating. Galaxies will continue evolving. Time itself will continue moving forward. The cosmos will simply become quieter. Much quieter. If the current universe resembles a bustling city filled with lights, movement, and activity, the far future may resemble an abandoned landscape beneath an endless night. There is something strangely peaceful about this vision. Not because it is cheerful, not because it is tragic, but because it reminds us that change is universal. Everything changes. Stars change. Galaxies change. The universe changes. Nothing remains exactly as it is. Human beings often resist this reality. We seek permanence, stability, certainty, yet the cosmos tells a different story. Its greatest structures are temporary, its brightest lights are temporary, even entire eras of cosmic history are temporary. And somehow that impermanence does not diminish their beauty. It enhances it. A sunset is beautiful because it ends. A season is meaningful because it passes. A star is extraordinary because its light is finite. The universe itself may owe much of its wonder to the fact that it is constantly transforming. Tonight, as ancient photons continue crossing intergalactic space, countless stars are shining for the first time. Others are reaching the end of lives that began before Earth existed. Across billions of galaxies, the story of light continues unfolding. Yet far ahead, beyond timescales almost impossible to imagine, the cosmos is already moving toward a quieter future. A future in which the great age of stars slowly draws to a close. One by one the lights will fade. The galaxies will grow darker. The night will deepen. And the universe will enter another chapter of its endless evolution, carrying the remnants of every star that ever shone into an age where darkness becomes the dominant feature of reality once again. Long after the final stars have exhausted their fuel, long after the last brilliant nebula has faded into darkness, the universe will still contain objects of extraordinary power. In many ways, the age that follows the stars belongs to black holes. Today, black holes already occupy a special place in our imagination. They are often portrayed as cosmic monsters, invisible traps lurking within the darkness, swallowing anything unfortunate enough to wander too close. Yet the reality is both stranger and more fascinating than the myths. A black hole is not an object in the traditional sense. It is a region of space where gravity has become so intense that escape is impossible. Not even light, the fastest thing in the universe, can climb back out once it crosses a boundary known as the event horizon. To an outside observer, the event horizon appears almost magical. It marks a point beyond which information can no longer return. Anything crossing that threshold vanishes from the observable universe forever. Yet black holes are not cosmic vacuum cleaners indiscriminately devouring everything around them. If the Sun were somehow replaced by a black hole of identical mass, Earth would continue orbiting almost exactly as it does today. The planets would not be swallowed. Their paths would remain essentially unchanged. Gravity at large distances depends on mass, not on whether that mass is compressed into a star or a black hole. The true difference emerges only when something ventures close. Very close. Close enough for gravity to reveal its most extreme behavior. Black holes form when massive stars die. After exhausting their fuel, the star's core can collapse under its own gravity with such overwhelming force that no known pressure can halt the process. Matter compresses into a state that pushes our understanding of physics to its limits. The result is an object whose gravity permanently reshapes the surrounding space and time. And the universe contains far more of them than most people realize. Nearly every large galaxy appears to possess a supermassive black hole at its center. The one residing at the heart of the Milky Way contains roughly 4 million times the mass of the Sun. Other galaxies host even larger examples. Some contain black holes with masses measured not in millions but in billions of suns. These giants sit quietly in galactic cores, exerting their influence across vast distances. For now, they coexist with stars. They coexist with galaxies. They coexist with a universe still rich in light. But as cosmic time unfolds, their importance grows. When the age of stars finally begins drawing toward its conclusion, black holes will remain. White dwarfs will cool. Neutron stars will cool. The remnants of galaxies will slowly evolve. Yet black holes will continue waiting in the darkness. Patient. Silent. Persistent. In many ways, they are among the most durable structures nature has ever created. Imagine a future universe trillions of years from now. The brilliant spiral galaxies we know today will no longer exist in their familiar forms. Stellar encounters will gradually alter their structure. Orbits will shift. Countless stars will be ejected into intergalactic space. Others will spiral inward through gravitational interactions. Over immense stretches of time, black holes become gravitational collection points. Like cosmic gathering places, slowly accumulating matter from their surroundings. The process unfolds so gradually that even millions of years become insignificant. Yet given enough time, enough stellar encounters, enough random interactions, the black holes grow. The darkness becomes their ally. The silence becomes their kingdom. And eventually, many of the remaining objects within galaxies may either be ejected into deep space or consumed. This leads to a remarkable possibility. Far in the future, some galaxies may become dominated by a central black hole surrounded by vast regions of emptiness. The bright stellar populations that once defined them will largely be gone. Only remnants will remain. A few cooling stellar corpses, wandering planets, occasional dark objects drifting through the void. And at the center, the black hole, waiting. Yet even here, the story grows stranger. For much of the 20th century, black holes were believed to be truly eternal. Once formed, they would remain forever. Nothing could escape them, nothing could reduce them. They seemed destined to survive until the end of time itself. Then physicist Stephen Hawking discovered something extraordinary. Black holes are not completely black. Quantum mechanics, the theory governing the microscopic world, predicts that black holes should emit a faint form of radiation. Today it is known as Hawking radiation. The effect is astonishingly weak. For large black holes, it is effectively impossible to detect directly with current technology, yet according to our best understanding of physics, the process is real. And it carries extraordinary consequences. Black holes slowly lose energy, slowly lose mass, slowly evaporate. The word slowly hardly does justice to the timescales involved. A black hole containing the mass of our Sun would require roughly 10 to the 67th power years to fully evaporate. Writing that number is easy, understanding it is another matter entirely. It is not millions of years. Not billions. Not trillions. Not even numbers for which ordinary language possesses comfortable descriptions. Compared to such durations, the entire age of the universe so far is effectively instantaneous. Yet no matter how long the process takes, the conclusion remains the same. Black holes are not eternal. Even they have an ending. This realization transformed humanity's vision of the far future. For a time, black holes seemed destined to outlive everything else. They appeared to be the final monuments of cosmic history. Yet Hawking radiation revealed that the universe continues changing even in its darkest eras. Nothing escapes time. Not stars. Not galaxies. Not black holes. The deeper physicists explored this idea, the more profound it became. Imagine a supermassive black hole sitting at the center of a galaxy long after the final stars have vanished. For unimaginable ages it remains nearly unchanged. Trillions upon trillions of years pass. Entire cosmic epochs come and go. Then, almost imperceptibly, it begins to shrink. The process is absurdly slow at first. But as the black hole loses mass, evaporation accelerates. Eventually, after timescales so vast they dwarf every chapter of previous cosmic history, the black hole reaches its final moments. And then, in a brief burst of energy, it disappears. A structure that survived for durations beyond imagination simply ceases to exist. The empire of black holes comes to an end. There is something deeply poetic about this. Black holes represent gravity at its most extreme. They embody collapse, permanence, and inevitability. For generations, they seemed like symbols of cosmic finality. Yet even they prove temporary. Even they are participants in the universe's endless transformation. The lesson appears again and again throughout cosmic history. Nothing remains unchanged forever. Not the stars. Not the galaxies. Not the largest structures in existence. Reality is a story of evolution unfolding across scales so vast that permanence itself becomes an illusion. What appears eternal from one perspective becomes fleeting from another. Human lives feel brief compared to mountains. Mountains feel brief compared to stars. Stars feel brief compared to galaxies. Galaxies feel brief compared to black holes. And even black holes eventually surrender to time. Perhaps this is why the universe feels so profoundly different from anything in everyday experience. On Earth, we instinctively divide things into categories: living and non-living, permanent and temporary, beginning and end. The cosmos blurs those distinctions. Everything exists within a continuum of change. Everything is moving through time. Everything is participating in a process larger than itself. Far ahead, beyond the age of stars, beyond the fatting of galaxies, beyond the reign of black holes, the universe will continue its journey into even deeper darkness. The great engines that once shaped cosmic history will gradually disappear. The brilliant lights of creation will be long extinguished. The gravitational titans that survived them will finally evaporate. And still, time will continue flowing forward. The cosmos will persist. Quieter than ever before. Darker than ever before. Entering a chapter so distant from our own era that the universe we know today would seem like a forgotten dream, a brief and luminous memory from a time when galaxies still shone across the darkness and black holes had not yet inherited the stars. There is a tendency when contemplating the future of the universe to imagine an ending, a final page, a last event, a moment when the story concludes and the curtain falls across existence itself. Human beings naturally think this way because every story we know possesses an ending, every life reaches a final breath, every civilization eventually becomes history, every star exhausts its fuel, everything familiar follows a narrative arc with a beginning, a middle, and an end. Yet the deeper we look into the future of the cosmos, the more we discover that reality may not offer such a clean conclusion. The universe does not appear to be moving toward a dramatic finale. It appears to be moving toward silence. By the time the final stars have faded and the last black holes have evaporated, the cosmos will have become almost unrecognizable. The magnificent galaxies that fill our telescopes today will be gone. The bright clusters that once illuminated the cosmic web will have dissolved into darkness. The familiar landmarks of astronomy will belong to a past so distant that even memory seems inadequate to describe it. The universe will not be empty, but it will be unimaginably quiet. The remaining particles will drift through an ever-expanding sea of space. Temperatures will continue falling. Distances will continue growing. Matter itself may gradually decay. Even the most stable particles known to physics could eventually disappear, although scientists remain uncertain whether this fate is truly inevitable. What is clear is that the cosmos becomes increasingly sparse, increasingly cold, increasingly dark. The great cosmic drama that once produced stars, planets, and galaxies slowly gives way to a simpler reality. A universe approaching equilibrium. A universe running out of differences. Because differences are what make events possible. A star shines because its core is hotter than the space around it. A planet supports weather because energy flows from one place to another. Life exists because matter organizes itself into structures capable of maintaining order against disorder. Every process in the universe depends upon imbalance. Heat flowing toward cold. Matter moving toward gravity. Energy spreading through space. Without differences, nothing happens. And in the far future, those differences gradually disappear. Physicists sometimes refer to this possibility as heat death. The phrase sounds dramatic, but the reality is surprisingly calm. It does not describe an explosion or a catastrophe. It describes a universe that has reached maximum entropy, a state where energy has become evenly distributed and no significant processes remain capable of occurring. Imagine a river flowing toward the sea. The movement exists because the water occupies different elevations. The moment the entire surface becomes perfectly level, the flow stops. The future universe may be similar. Not destroyed. Not shattered. Simply still. The stars are gone. The black holes are gone. The great engines of cosmic change have fallen silent. Only a thin scattering of particles remains, drifting through darkness that stretches beyond comprehension. And yet even here, uncertainty remains. Modern physics continues searching for answers about the deepest nature of reality. We do not yet possess a complete theory capable of describing everything. Quantum mechanics governs the microscopic world. Relativity governs gravity and the large-scale structure of the cosmos. Both work extraordinarily well, yet they remain incomplete pieces of a larger puzzle. Because of this, the true fate of the universe remains unknown. Perhaps dark energy continues accelerating expansion forever. Perhaps it changes. Perhaps entirely new physics emerges on timescales we cannot yet imagine. Some theories suggest that quantum fluctuations could eventually create new structures from apparent emptiness. Others propose cycles of cosmic rebirth. Still others hint at possibilities so strange that they challenge the limits of language itself. The farther into the future we look, the less certain our predictions become. And there is something beautiful about that. After traveling across billions of light years, after crossing the cosmic web, after exploring the vast voids between galaxies, after watching stars ignite and fade, after witnessing the rise and fall of black holes, we arrive not at certainty but at mystery. The mystery remains. Perhaps it always will. Because the universe is larger than any single explanation. Larger than any theory. Larger than any observer. Humanity has spent centuries expanding the boundaries of knowledge. We have learned that Earth is not the center of the solar system. The solar system is not the center of the galaxy. The Milky Way is not the center of the universe. Again and again, reality has revealed itself to be far greater than our initial assumptions. And perhaps that lesson is the most enduring of all. The universe is not obligated to fit comfortably inside the human mind. It never has. Yet somehow we continue trying to understand it. Tiny creatures on a small world orbiting an ordinary star have managed to trace the history of the cosmos back nearly 14 billion years. We have mapped galaxies across unimaginable distances. We have measured the afterglow of creation itself. We have discovered black holes, dark matter, and the expansion of space. We have learned enough to know how much remains unknown. And perhaps that is the true gift of astronomy. Not certainty. Perspective. The realization that our lives unfold within something vastly larger than ourselves. Every worry, every ambition, every triumph and every disappointment. All of it occurs on a pale world drifting through a galaxy that itself drifts through an ocean of darkness spanning billions of light years. At first, this realization can feel insignificant. But with time, it begins to feel liberating. Because the universe is not merely large. It is astonishing. The atoms within your body were forged in ancient stars. The light entering your eyes tonight may have traveled for millions or billions of years before reaching you. The elements that make life possible emerged from cosmic processes stretching back to the beginning of time itself. You are not separate from the universe. You are one of its expressions. A brief moment in which the cosmos becomes aware of itself. And while that moment may be temporary, it is no less remarkable for being so. The stars will eventually fade. The galaxies will eventually change. Even the largest structures in existence will not last forever. Yet tonight the universe is still bright. The galaxies still shine. Ancient photons are still crossing the darkness between worlds. The cosmic web still stretches across the observable universe like a vast architecture of light and shadow. And here, for a brief moment in cosmic history, there are beings capable of wondering about it. Capable of looking upward and asking questions. Capable of imagining distances so large they defy comprehension. Capable of finding meaning within the silence. Perhaps that is enough. Perhaps the value of the universe is not that it lasts forever. Perhaps its value lies in the fact that it exists at all. That stars were born. That galaxies formed. That life emerged. That consciousness appeared. That for a short span of time, the universe produced observers capable of appreciating its beauty. As the night grows quieter and your thoughts drift gently toward sleep, allow yourself to rest within that perspective. The cosmos does not demand anything from you, it asks for no conclusions, it offers no final answers. Only wonder. Only scale. Only the quiet reminder that reality is far larger, far older, and far more mysterious than it first appears. And somewhere beyond the stars, beyond the galaxies, beyond the furthest horizons of observation, the universe continues its endless journey through space and time. Silent. Ancient. Beautiful. Waiting. Thank you for joining this journey through the deepest reaches of existence with space sleep theory. If you enjoyed this exploration of the universe, its mysteries, and its distant future, consider subscribing and returning for more voyages into the cosmos. Until next time, sleep well, dream deeply, and let the stars carry your thoughts gently into the night.